Dear students, this video is on trigonometric identities, a topic from class 10, one of the most important topics. So watch it carefully. We are going to understand the derivation of identities. Trigonometric identities. We know identity is actually an expression in which LHS, RHS become equal. So any equation where LHS RHS is equal is identity, and when you are dealing with trigonometric identities, it would have trigonometric functions. Like over here we need to prove, this is the first identity, sine square theta plus cos square theta is equal to 1. This is the basic identity. Now let us see how do we prove this. For that, first thing which you should have is, we should know how Pythagoras is applied in right angle triangle. Observe this triangle ABC, which is having 90-degree angle at B, and angle C, theta is taken at the vertex C. If I apply Pythagoras, it would be AC square is equal to AB square plus BC square. Okay, this is direct application of Pythagoras theorem. Next is, if I divide both the sides by AC square, AC square is divided by AC square, AB square divided by AC square, BC square is divided by AC square. Now why did we divide it by AC square only? Look at this complete equation. It has 1 on other end. It's sine square theta plus cos square theta is 1. If you want to obtain this 1, AC square, if is divided by AC square, ultimately would give us 1. But now let us see, do we get trigonometric functions out of these two, which are ratios? Okay, cancelling this becomes 1. So 1, I should say LHS RHS is obtained. Let's see, what is AB square by AC square? AB by AC whole square. BC square by AC square can be written as BC by AC whole square. Observe the figure now. Switch to figure. AB by AC. What is AB? It's perpendicular. Okay, perpendicular. What is AC? This was hypot. What is perpendicular upon hypot? But what is that ratio? That ratio is sine of theta. Sine theta whole square. What would be BC by AC? BC, since theta is formed here, this side is base. BC by AC is cos theta. Cos theta is squared. And we have already discussed sine theta whole square or sine square theta, cos theta whole square or cos square theta is one and the same thing. So this proves your very first identity, the most important identity and the basic identity. In fact, from here, two more results can be obtained. We call them conversions, because at times, depending on the question's condition, we may be asked to express sine in terms of cos. So what would you do in that case? Let me just pick up this only. As we know that sine square theta plus cos square theta is 1. Okay, if this is 1, that implies sine square theta, depending on the question's demand, can be written as 1 minus cos square theta. Same way, cos square theta. Same way, cos square theta can be written as 1 minus sine square theta. So these two are conversions, and this is the basic identity. So always remember, sine square theta plus cos square theta would always be 1. Now we would see how it would be applied in questions. Now in a row, the next identity is related to these functions tan square and sec square. We need to prove that 1 plus tan square theta is secant square theta, and to prove this we would move on and we would pick up our basic identity, basic trigonometric identity, which was that sine square theta plus cos square theta is equal to 1. Okay, always remember sine square theta plus cos square theta is 1, and using this result we would be proving this identity. And to understand that how they are related, you must remember one more thing. Sine, cosec are reciprocals, we have already discussed. Yeah, as tan theta is sine upon cos, it was discussed in previous video, and if tan's reciprocal is cot, then cot can be expressed as cos by sine. And other reciprocals, the partners which were discussed, sine and cosec. Sine is actually 1 by cosec, cos is 1 by sec, and tan. How can we write tan? Tan would be tan is 1 by cot. Sine, cosec are reciprocal. If sine can be written as 1 by cosec, cosec can also be written as 1 by sine. So now let's focus on the basic identity. This identity, which was sine square theta plus cos square theta, is 1. If I dividing both sides by, dear students, listen, it's very simple. We know this is sine square, cos square is equal to 1. 1 has to become secant square theta. Secant is reciprocal of cos. If I divide this whole equation by cos square theta, look at the changes which would be there in this basic identity. Sine square theta is divided by cos square theta. Cos square theta is also divided by cos square theta, and over here 1 is divided by cos square theta. Sine by cos, just now we have seen sine by cos is tan. Since it is in square, so tan square theta. Cos by cos would be cancelled. Answer resultant is 1. 1 by cos. Cos and secant are reciprocal. So this is secant square theta. That's it. Very simple it was. So that's how your basic second identity is proved. Conversion. From here, two conversion identities can be made. At times there are questions in which we have just one is given. So 1 can be replaced by tan square theta minus secant square theta. 1 or minus 1? Minus 1. Because you would see many interesting questions where the question has got some formation, tan square minus sec square, replace it by minus 1. Or what else can be said, can be obtained from here? Or sec square theta minus 1 will be sec square theta minus 1 would be tan square theta. Okay, you can rearrange this why to take minus 1? Let's rewrite this. It would become secant square theta minus tan square theta. Secant square theta minus tan square theta is equal to positive 1. So these two are conversion identities. This was your basic second identity. So in all 6 are done, 3 more are there. If I say 3 more, I am talking about the third basic and 2 conversion identities which would be obtained from the third set. Next one is 1 plus cot square theta is cosec square theta. For this even we need our basic identity, which is that sine square theta plus cos square theta is 1. Alright, now what do you think? If we divide, initially we divided it by cos square. Now dividing both sides by sine square, it's easy. Why sine square? Because cosec, how would you get cosec from 1? 1 by cosec would be sine. So 1 by sine would become cosec. Pick up this, divide the whole by sine square theta. Sine square by sine square. This is cos square theta by sine square theta and 1 by sine square theta. Perfect. Sine square cancel. This gives you 1. Cos by sine is cot. Since it's in square, so this would be cot square theta. 1 by sine means reciprocal of sine is cosec, and that's it. So that's how even our third identity is proved. From here to conversion identities. Conversion is just according to the convenience, according to the demand of question, how we would rewrite various terms of this identity. At times you may get just 1. 1 can be written as cosec square theta. It can be written as cosec square theta minus cot square theta. Okay. And at times you may be just asked to replace cot square theta. Cot square theta, what would it be? That would be cosec square theta minus 1. That's it. So perfect. Your basic identity should, if you remember this basic identity, once divide the whole by sine, next time divide the whole by cos, and the complete series of trigonometric identities would be obtained. It's very simple. I'm sure this must be clear to everyone.
And yes, for the application of these identities, watch the next video in which we have some important questions from exercise 8.4.